Swinging on a riverboat, not a rare sight on the River Elbe near Hamburg, but in nearby Buxtehude, the swing was the center of attention. That was in November 2000, where at the site of BMH Claudius Peters, the slogan was "Swing is in." More than 90 guests from 17 nations came to Buxtehude to see the live presentation of the latest development in CoolerTechnology. Managing Director Alfred Rothländer welcomed the experts from the cement industry and introduced the company and its products.
All of you know Claudius Peters from your business. For more than 90 years, this brand stands for excellent equipment and technologies and processes within the industries, such as raw meal, blending silos, cement silos, pneumatic conveying dispatch systems, and last but not least, clinker cooler.
Mr. Rainer Frühling, Director for Global Cement, gave a short description of BMH Technologies.
Presence in the world. The companies forming the BMH Technologies have complementary products and services and can therefore cover together major technologies of different industries.
Before the hands-on live presentation, the first item of the day gave detailed information about the new BMH compact swing support CoolerTechnology. In 3 presentations, divided into language groups, BMH engineers gave an insight into the theory and operational features of the new technology.
Als wesentliches Bestandteil unserer neuen Kühler gilt heute ein HE-Modul, welches wir in den Anfängen in vorhandene Kühler eingebaut haben.
The news was met with great interest and enthusiastic discussions took place during the presentations.
It's quite similar to what we will see in the afternoon in our workshop. It's a complete cooler lower part. And we have, for this swing festival, prepared one cooler lower part here with all these features.
After the theory came the practice. The second item on the agenda allowed the guests to understand the manifold scope of production during a plant visit. BMH Claudius Peters in Buxtehude has manufactured components for the cement industry and many other industries since 1954. The products include packing machines, flow control gates, two-way valves and the proven BMH Claudius Peters X-Pumpe. There was also a lot to see in the technical center. Based on the technology available in the technical center, the engineers explained the many possibilities for product and procedure development at BMH. Materials, machines and even whole plants can be tested in the technical center and optimized for practical use. Pneumatic conveying tests and grinding tests of minerals, coal and petroleum coke are carried out in this facility. Furthermore, it is possible to model the operation of silos with mechanical discharge systems. In the company-owned laboratory, material tests are constantly carried out. Over the years, a data bank of thousands of different materials has been built up, which is used as a basis for the design of new plants. Further important elements which are developed and manufactured at BMH include automation and control systems. A very different field of production at BMH is the manufacture of the so-called stringer for the Airbus program. Due to the proximity of the Hamburg EADS Airbus plant to Buxtehude, this interesting field of production developed 20 years ago. The longitudinal reinforcement profiles for the aeroplane hull made of different aluminium alloys are carefully formed and heat-treated in special processes with constant quality control. More than 3,000 different components are manufactured and are used in all Airbus aeroplanes. Maybe you will think of BMH Claudius Peters in Buxtehude during your next flight in an Airbus. But back to the main topic of the day, the compact swing support cooler. In the assembly hall, the guests could view a finished cooler grate for a cement production line, complete with HE module and hydraulic cylinder drive, designed for a capacity of 1,800 tons a day. The feeding grade was especially interesting for most. For many visitors, it was the first chance to get familiar with the function and operation of such a grate. Very quickly, an interesting discussion took place. Through various discussions, all details were explained and described using graphical illustrations. Today, complex automation is an integral part of modern cooler plants. BMH Claudius Peters lays special focus on the latest developments in measuring technology, for instance the level radar, which is used to measure reliably the material height in the high temperature areas of the clinker cooler. To explain the construction and operation of the newly developed elements of the BMH cooler, we will show you once again the essential components of the compact swing support cooler, CSS for short. The pictures were taken during the 3-week building phase at site in Buxtehude. The simple assembly of the CSS module is clearly visible. In only approximately 10 minutes, the module is mounted under the fork carrier and screwed to the lateral wall of the cooler lower part. The simple assembly is, of course, a major advantage for future modifications of a cooler. The new BMH cooler is completely equipped with slot plates. Installation of the plates starts at the lower end of the cooler, farthest away from the material inlet. In this assembly phase, the principle of the thrust grade cooler is clearly visible. Movable and fixed rows are assembled alternately. Movable rows rest on so-called swing frames, fixed supports on the lateral wall. A grate plate weighs about 25 kilograms and is simply installed from the top. To close the gap between two adjacent grate plates, the installation engineer inserts a sealing strip. This sealing strip prevents material riddlings during operation of the cooler. The plates are fastened with T-bolts, which are prevented from loosening by a pre-tightened spring. BMH's new plate type can also be used on older coolers. This applies to one-piece chamber aerated grate plates as well as to two-piece directly aerated grate plates. Hard armoring on the sides of the plate in the thrust area and on the welded pieces gives optimum wear protection. In this way, extremely high lifetimes are achieved. Special plates, such as narrowing or bridging plates, are used to reduce the velocity of the material transport. These plates can be used as required over any of the grates and can be mounted easily with a T-bolt. Another important component to minimize material riddlings is the lateral seal of the grates. This is also equipped with hard armoring and can easily be exchanged. The so-called HE module is located in the inlet area of each BMH cooler. This is a stationary, fixed area with directly aerated slot plates. Let's look at the operation of the clinker cooler in motion. Due to the compact swing support bearing, the plant is maintenance-free for many years. The ingenious principle of the CSS is visible in the following animation. The two outer thin spring assemblies are tightly tensioned at the top end and connected at the bottom in a triangular arrangement. At the upper point of the triangle, the third, central spring is fastened. The swing frame is suspended from the lower end, marked red here. The CSS works like a pendulum, twice its size. Because of this, the lower end of the central spring follows virtually linear movements. This ensures that the gap between the movable and fixed grate plate rows stays minimal over the entire movement. It can also be seen that to the left and right of the central spring, the fork head of the swing frame lies in the CSS. The outer 6 conical coil springs control the movement of the upper point of the triangle and the swing damping. Inside the cooling air chambers, the CSS module is effectively protected with a housing. The swing frame of the new cooler is centered by a patented spring steel sheet. How does this work? Two pre-tensioned pairs of steel spring sheet are positioned at the front and rear end of the swing frame. Each sheet is fastened at the lateral wall of the cooler and at the furthest opposite beam of the swing frame. During operation, lateral excursion is prevented, ensuring parallel movement. With this new type of construction, BMH's technical designers have made sure that no maintenance is necessary in this part of the cooler. The hydraulic drive consists of 2 cylinders driven in parallel, each positioned at the longitudinal side of the cooler. The contact-free displacement transducer is coupled with the so-called GMC, Grate Motion Control Box. The computer-supported system ensures consistent stroke lengths at all speeds. The result is an optimum low number of strokes. This new technology can also be integrated in existing plants with minimum effort. The proven sliding plate system on the driving axle prevents air escaping from the chamber. To keep the loss of cooling air flowing from one chamber to the other as low as possible, the gaps at the openings for the beams are kept to a minimum. In the generous air chambers, the cooling air can spread under the grate and enter the material bed evenly distributed through the numerous slots in the plates. An important precondition for efficient cooling is that gaps between movable and fixed grate plates are kept to a minimum. The armored pre-welded parts contribute considerably to this. All these measures lead to one result: high availability of the system and efficient cooling performance. As mentioned previously, BMH Claudius Peters also develops highly advanced measuring systems to optimize the cooler plant as far as possible. One of these measuring systems is the BMH level radar. Unlike traditional measuring devices, the level radar measures the clinker bed height precisely without the detrimental effects of dust and high temperatures. The level radar is installed in the kiln head. The level radar sends microwaves from the sensor to the material bed. This reflects the waves which are caught by the receiver and analyzed by the system. For gas temperature measurement, BMH has developed a fast reaction pyrometric measuring probe which allows an improved thermal assessment of the clinker cooler. The presentation was concluded with the BMH roller crusher. This type of crusher has been in use in the cement industry since 1979 and has shown excellent availability and low maintenance in more than 40 plants. Today the roller crusher is not only used as a hot crusher for intermediate crushing, but also as an alternative for high-wear hammer crushers. At the end of the Swing Festival, everyone agreed that. Many interesting discussions have helped to strengthen the good cooperation between plant operators and supplier. There was one thing that BMH Claudius Peters wanted to convey to its customers on this day. We won't leave you standing out in the rain. Of course, the social life was not forgotten during the Swing Festival. With swing music by the Buxtehude Hedgehog Stompers, cool drinks and Nordic cooking, the day reached a relaxing conclusion.